Test, test. Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing Stats and Math at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both high school level and college levels. And if you need some homework help or tutoring, please check out the link in the description below. So now let's start our session. Alright. So our first question today is asking us how to find the domain of a function. Cool, so let's copy down the question first. How to find the domain of a function. Right. So functions are often described as a machine in a box that is open on two ends, and you put something into it in one end of the box, and it gets changed inside the box, and then the result pops up to the other end. And the function is a machine inside the box, and it is defined by what it does to whenever you want to, whenever you put into it. So here's the function, and then we put something into this function, and then we will get our result. So a mapping of function, I'll write this part down. A mapping a mapping or function f in AB from set A to set B set A to set B to be the special type of relation where AB belongs to F for every element A belongs to A. There exists a unique element B belongs to B. And another way of saying this is that for every element in A, F assigns a unique element in B. And we usually write this down as F A B. And instead of writing ordered pairs AB belongs to, how is this down? Instead of writing AB belongs to AB, we write FA is equal to B. And the set A is called the domain of F. Set A is called the domain. It's called the domain of F. And FA is equal to FA belongs to B. It's called the range. Where we see the image of F. And we have often described the elements in the function's domain as input values, and the elements in the function's range as our output values. So come back to our original graph. So that's domain range. So that's sort of like the input and output. Right. So let's use some examples to give you a better understanding of what domain is. So first, let's say we are given a table of values. So something like this. So that's x and y. So we're given certain values. Right. So in this case, let's write down our domain. The domain will be our x values, which are -2, -1, 0, and 1. And our range let's say, will be our y value, which is still 0, -2, -1, 0, and 1. And so that's the first example. The second example, let's say we're given a function that is defined by fx is equal to x squared minus 2x plus 1. So in this case, we need to think all possible values of x that will satisfy the given function. And in this case, the possible values of x are a set of real numbers. Yeah, it's a possible value of set of real numbers. So x could be anything from real numbers. Because when we draw the graph of this function, it should be something look like this. Oops. Yeah. So in terms of x value, it could be anywhere on the x-axis. So, and for third example, let's see an ordered pair given by -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. In this case, our domain is going to be -2, -1, 0, 1, and 4, which are the x value in each coordinate. Right. And okay, so our fourth example, if we are given a function look like this, so as you can see, the x part is as a denominator, is as a bottom. So in order to make this function valid, we need to make sure the denominator cannot be equal to 0, which means x minus 1 cannot be equal to 0, which gives us x cannot be equal to 1. Therefore, the domain for fx is x belongs to real numbers and x cannot be equal to 1. Yep, so that's all we have for this question. Let's leave a comment there. Okay. Our second question. It's asking us, how do you write the equation in the slope-intercept form? Given -3, 5 and -6, 8. Right. So first, let's recall what a slope point form of the equation of the line looks like. So the first thing, slope intercept form. It is given by y1, y minus y1 is equal to m times x minus x1, where m is our slope and x1, y1 is a point on the line. So now let's go back to our question. So in order to find the given 2 points on the line, we substitute x1, y1 is equal to -3 and 5, and x2, y2 is equal to -6, 8, which is from the question. So -6, yep. Yep, so that's our x1, y1, and that's our x2, y2. Therefore, we can calculate the slope. So next thing would be calculate the slope. Yep. So, as we're given that y minus y1 is equal to m times x minus x1, so m is also equal to y, this is just y2 and x2. So x2 minus, y2 minus y1 over x2 minus x1 is equal to m, which is our slope. And now we just need to substitute the number back in there. So m is equal to y2, which is 8, minus y1, which is 5, over x2, which is -6, minus x1, which is -3. Remember to put a bracket. And yeah, let's just solve this. So a minus 5, which is 8, And for -6 minus -3 is just -6 plus 3, which is 3 over -3, which is -1. Therefore, we have our slope m is equal to -1. Right. So now we just need to substituting back the calculate the slope and the point into the equation. So substitute calculate slope and point x1, y1, which is -3 and 5 in the equation. So we have y minus 5 is equal to -1, which is our slope, times x minus -3. Right. So left hand side is still going to be y minus 5, and that's going to be -1 times, because x minus -3, it just becomes to x plus 3. So y minus 5 is equal to -3 minus 3. And now we're adding 5 on both sides. I'll write this down. And the reason why we're doing this is because we want to leave y on one side. Adding 5 on both sides. Thus we will have y is equal to negative x minus 3 plus 5, which could give us y is equal to negative x plus 2. Right. Oops. I think there was a, yeah, this should be the slope point form. There was a typo. Yep. So therefore, we can, therefore, the slope intercept form of the equation of the line passing through the point -3 and 5 and -6 and 8 is y is equal to negative x plus 2. Right. Yeah. So that's the end for this question. And we can also always to check if it is the correct answer. So let's say if we want to substitute -3 and 5 into this question, we will get 5 is equal to negative 3 plus 2, which is just 3 plus 2. So that is checked. And also, we can substitute the -6 and 8 back into this equation, which we will get 8 is equal to -6, so it becomes a positive 6, and then plus 2, which is still going to be 8. Yeah, so that is correct. Okay, so let's leave a comment there. All right. So coming up, we're given questions asking us why is cosine pi and cosine negative pi both equal to both equal to -1. Okay. All right. So first, let's draw a unit circle. And yep. So in a circle, 1/4 round is equal to 2 pi, which means if I start from here and I go around, come back there, that's going to be 2 pi. And if I only go halfway, which means I start from here and stop right here, that's going to be 1/2 of 2 pi, which is just going to be pi, right? Okay. So pi will be equivalent to half a circle, and if pi is positive, the direction will be counterclockwise, and if it is negative, the direction will be counterclockwise. Oops. I mean, if it's positive, it is clockwise. Let me write this down here. So, pi is equivalent to a half circle if pi is positive the direction will be counterclockwise and vice versa. Oops. So if it is negative, it is clockwise. Right. So if we view this circle as a unit circle with the center as our origin, 0, 0, and we see that the cosine is just x value. Write this down here. Cosine is the x value, while sine is the y value. Right. So in the figure above, the x value corresponding to pi is -1. So therefore, cosine pi is equal to -1. And the positive and negative sign of pi only denotes the direction of rotation. I'll write this down here. So positive and negative sign of pi only denotes to the direction of rotation. All right. Okay. So now let's leave a comment there. Okay, so coming up, we're asking how to simplify sine pi over 3, right? So by angle conversion, we know pi over 3 is just 60 degrees. So we can first write that down. So pi over 3 times 180 degrees over pi, which is like a conversion factor. And so this becomes 180 degrees divided by 3, so that's 60 degrees. And things is the 60 degrees, and it is a right triangle. So, and there's a property of special triangles. We have the following conclusion. First, let's write down, draw the figures out. So that's 60 degrees, and that's 90 degrees, and that's 30. And so that's 2x, x, and root 3x. Right. So the sine function. The sine function can be computed as sine 60 is equal to opposite over hypotenuse, where this is our opposite and 2x is our hypotenuse. Right. So this is just going to be equal to root 3x over 2x. And since we got an x for both the denominator and numerator, so we can get rid of the x. So we have root 3 over 2 left. Therefore, let's write our conclusion. Therefore, sine pi over 3 is equal to root 3 over 2. Or we can write it as 1 over 2 times root 3. Doesn't really matter. Yep. So that's the answer for this question. Good job. Okay. So now we have a question. How do we simplify sine pi over 3? And so still first by angle conversion, we know the pi over 3 times 180 degrees over pi is equal to 60 degrees, where 180 over pi is sort of like a conversion factor. So now instead of solving sine pi over 3, we're actually doing sine 60 degrees, right? And so that is a special triangle. And recalling the figure of special triangle of 60 degrees, it should be something look like this. So 60, 30, 90, right? And that's 2x, root 3x, and x. Right. And now the sine function can be computed as sine 60, and with respect of 60 degree angles, we know the opposite should be root 3x, and hypotenuse should be 2x. Hypotenuse. All right. So this is equal to opposite over hypotenuse, which is equal to root 3x over 2x. And since we got an x for both top and bottom, we can cancel it out. So we have root 3, root 3 over 2 as our answer. Okay. So let's write down the conclusion. Therefore, sine pi over 3 is equal to root 3 over 2. Yep. So let's leave a comment there. Okay. Okay. So our next question is asking us, how do we graph y is equal to x? All right. So graphing y is equal to x. All right. So the form of the equation y is equal to x indicates that this is a linear equation, which is a straight line. So first let's write that down. Straight line and linear equation. Right. And using the slope intersect of a linear equation, which is y is equal to mx plus b, we can see that the slope of the given line is 1, because we can imagine there's a invisible 1 in front of x, and its intercept is 0, 0. As you can see, there's nothing after x, right? And to graph the line, we need 2 points. And we're already in the 1 point, which is the origin, 0, 0. And now we just need to find another point, and we can do this by using any x value and finding its corresponding y value using the given equation. All right. So let's write it down here. To graph a line, we need 2 points. And 1 point, 0, 0 is given. We need to find another point. And we can do this by using any x value and finding its corresponding y value. using the given equation. All right. So let's say we want to use x is equal to 1. So we use x equal to 1. And we call the equation it is going to be y is equal to 1, right? Because we're just substituting x by 1. And so our point will be 1, 1. Yeah. So now, as you can see, we have 0, 0, we have 1, 1. So in other words, we can build a straight line. Okay, so noted, now we have 0, 0, 1, 1. We can plot these points and form the line. And remember to extend the line past these points. Since it goes infinity, thus the graph should look like this. So let's say that that's our origin 0, 0, and that's 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1.0. Oh, that's our x-axis and y-axis. Therefore, that's 0.2, 0.4, 0.6, 0.8, and 1.0. So recalling the 2 points are 0, 0, and 1, 1. So that's 0, 0. So I'll zoom in a bit. 0, 0, and 1, 1 should be somewhere like this. And then we connect them and extend on both sides. Yeah. And oh, and don't forget to write your equation beside your line. Beside your graph. So y is equal to x, and we can also label it here. So that's 1, 1, and 0, 0. Yeah. So I think that's how the graph looks like. And remember that you can use any point as long as you use a given equation, and it will always lead to the same graph. Like for say, if you use 2, 2, then you'll get some point right there. Like if you use when x equal to 2, and you can even use when x equal to 50 or 100, doesn't really matter. And as long as you use a given equation, which is y is equal to x, and this will always lead you to the same graph, which is something look like this. All right. So I think that's all we have for this question. Let's leave a comment there. Correct. Okay. So coming up, we have our next question. It's asking us, what are congruent triangles? What Okay, so let's write down the definition first, and then I'll show you some examples. So, definition. So congruent triangles are two or more triangles that have the same size and shape, which means their side length and angle measures are equal. Their side length and angles measures are equal. Yeah. So let's say we got two triangles. So this triangle ABC and that's DEF. If these two, let me write it down. So if these two, just like triangle 1 and triangle 2, if triangle 1 and triangle 2 are congruent, we will have the following properties. In terms of size, we have length of AB is equal to length of DE. So AB, DE. Length of AC is equal to length of DF. So AC, DF. And our hypotenuse, which is length of BC, is equal to length of EF. Right. And in terms of angles, the measurement of A is equal to measurement of D. So, yep, so it's right here. And the measurement of C is equal to the measurement of F. So C and F. And last, measurement of B is equal to measurement of E. So B and E are having the same degree of angles. Yeah. And I think that's what we need for this question. And I'll just add a little bit more about some rules or theorem for congruent triangles. So, rules or theorems for congruent triangles, which are SSS, which is stand for side, side to side, and we have our SAS, which is side, angle, side. And also we have our AS, which is angle, angle, side. And ASA, which is angle, side, angle. And finally we have our HL, which is stand for hypotenuse, leg. So those are the congruent rule. Congruence rule. Yep. Yeah, so I think that's all we need for this question. Let's leave a comment there. Solution. Is correct. Good job. Okay, so our next question is asking us, just let me zoom in a bit. So, what is the integral of sine x from 0 to 2 pi? All right. So, first let's recall that if we want to take the integral of sine x, let me write this down here. So recall the integral of sine x dx. This will be equal to negative cosine x plus c. And this is our trigonometric rule of integration. And c is constant. Right. So now let's go back to our question. So integral, as I mentioned in the question, is from 0 to 2 pi, which indicates our lower bound is 0 and our upper bound is 2 pi. Right. And then the integral is just going to be sine x and dx. Right. So the first step, we're taking the integral using trig rule. So we will have negative cosine x, and lower bound keep as the same. So upper bound and lower bound are the same. So from 0 to 2 pi. Right. So and then we just substituting the limits to the integration. Substituting the limits to the negative cosine x. Which is negative cosine 2 pi minus negative cosine 0. Right. And this will give us negative 1 minus negative 1. So we have negative 1 plus 1, which is 0. Therefore, cosine 0 is equal to cosine 2 pi is equal to 1. And yeah, so now we can write our conclusion. I'll just add a little bit right here. So cosine 0 is equal to 1. Cosine 2 pi is equal to 1. Yeah. And therefore, from 0 to 2 pi, sine x dx is equal to 0. Right. So that's all we have for this question. Let's leave a comment there. So next we have what is the derivative of ln x? Okay. So now let y is equal to ln x. Therefore, e to the exponent of y is equal to e to the exponent of ln x, which gives us e to the exponent of y is equal to x. And now let's take the derivative. So dy dx ey is equal to d dx x, where dy dx ey is just equal to 1. And now we have established that e to the exponent of y is equal to x, and we're substituting this into the equation above. So we have as we have x is equal to e to the exponent of y. So we have dy dx x is equal to 1, and dy dx is just equal to 1 over x. Yeah. So therefore, the derivative of ln x is 1 over s. And let's leave a comment there. Sure. Okay. Yeah, so Yeah, I think these are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and the notification bell below. And if you'd like to submit your own questions, please visit the links in the description. And remember to leave a like and a comment and share this video with your friend. And this has been Andrew from OneClass. I hope to see you soon. Bye.